Hi all, and welcome to the beginning of your last really short unit of Pre-Calculus, Chapter 9. We're going to talk about solving systems of equations. I know this video looks a little bit different. It's all filled in. There's two reasons. One is that I'm having some weird technical difficulties and I can't erase the notes that I've created. And two is the reason that most students I've ever had have come in being pretty sufficient on this topic already. So I'm going to go through a couple of steps with you, especially some graphing calculator steps in a little bit. So if you want to skip around and look at different problems from here, and if you want to skip ahead to talking about using your graphing calculator, feel free to skip ahead until you can find this being addressed. But most students come in knowing how to use the elimination method to solve systems of equations. You've got two problem sets for today and tomorrow, one from 9.2, one from 9.1. Again, I apologize, the fact that this video is a little odd, but hopefully most of you feel confident in using these strategies. So get yourself ready for notes. Also, you are going to have an end of the year test that will be May 27th and May 28th. If you haven't signed up for your Zoom call yet for the previous test, please do that quickly so that I can talk to you about what that test is going to look like and you can get the information to help yourself prepare for that exam. So looking at systems of equations, we're going to start off with what most of you are familiar with, the elimination method, the substitution method, and then graphing. So for the elimination method, I use this for most of them, especially when they are like terms. So we've got our x's and we've got our y's. So the elimination method, you want to make sure that a variable has the same coefficients, so 2y and 2y, and then add or subtract to eliminate that variable. So in this case, we're looking here, we see we've got a 4x and an 8x. They don't quite match, so I multiplied both sides by 2 of this equation to get 8x minus 6y equals 11. And then I have the old equation 8x, 4y, and 12. Then the x terms match when I subtract everything. Notice I'm subtracting. Then I get rid of the x terms. They are eliminated. And I end up with negative 6y plus a negative 4y, which gives us negative 10. Then 22 plus negative 12 is positive 10. So therefore, y is equal to 1. We then want to make sure that we still solve for x. You can plug back into the original equation or any of the intermediate ones. We know that y is now equal to negative 1. So 4x minus 3y equals 11 from up here can be solved to tell us that x is equal to 2. The answer will be usually written as an ordered pair, just in alphabetical order if it's not x and y. So if it's a or b, a is going to come first. In this case, 2, negative 1. That's the elimination method. Substitution method, the idea here is I will sometimes use this if I don't have both sets of like terms. So if I wanted to use the elimination method, I'm going to isolate one variable. So in this case, just added the y over here, so then x plus 3 is equal to y. Y is by itself, it's isolated. Could have isolated the x, you just want to pick. Generally, this one's a little bit easier. Then I'll substitute, meaning I'll get x squared plus y equals 9. Make sure you're substituting in the other equation. So here I solved with the second equation, plugged it into the first. So then I get x squared plus x plus 3 equals 9. And then this is a quadratic that I can solve. Set equal to 0, factor. I get x is equal to negative 3 and 2. In this case, that means there's two solutions. So I'll take this equation here. When x is negative 3, y is 0 for this point. If x is 2, y is 5 for this second point. So just, if you have two answers, that's fine. Get two equations. The last method that will maybe be new for some of you is graphing. And the way that it'll be new is that you might have to use your graphing calculator. So the idea is that when you graph your system of equation and you find the intersections, that's it. Those are the sort of ordered pairs. that are a solution here. Make sure you're only using the graphing method where it says I am going to expect to see shown work for all the others. So here it says our system is x squared minus y squared equals 3, y equals x squared minus 2x minus 8. So what I'll do is I'll graph these in my graphing calculator. This bottom one's already in function form, y is by itself, so I could just type that in here into my graphing calculator. For this step, I'm going to have to write them as functions, so that means solve for y. So I'll subtract x squared on both sides, get rid of the negative, and then get rid of the root. Since it's plus and minus, notice how I've got two equations, positive root x squared minus 3, negative root x squared minus 3. So the positive one is these two arcs, and the negative one is these two green arcs. And together they form the graph that would be x squared minus y squared equals 3, which is called a hyperbola. So once we graph them, we can see that we have 1, 2, 3, 4 intersection points. And in order to find those points, because they don't happen at nice numbers, you're going to want to go to second calc, so that you're on the trace button, so that right where you find max and min and roots, you're going to use intersect. So then first you're going to, you'll see the cursor pop up, maybe it's over here, maybe it's down here. And you want to just scroll until it's really close to an intersection. You'll say, okay, first curve, click enter. It'll bounce to another one that's close by, click enter. And just repeat this 4 times or for however many intersections, and then it'll tell you what that point is. It'll tell you the x value down here, which would be negative 1.87, and the y value. And you just want to make sure that you're moving your cursor close to each intersection point so that you can get each individual one on its own. Now there are a couple of word problems. Here's an example. The main thing with the word problems is making sure that you are writing the equations correctly. So you're going to need 2 equations for all of these because you're going to have 2 variables. Usually one will represent total and then the other one's going to have coefficients. So for example, the admission fee at a pool is $150 for children, $4 for adults. So those would be the coefficients, the money. On one day, 2,200 people entered the pool and the admission fees collected were $5,050. How many children went to the pool that day? So I've got dollars, dollars, and dollars. That means that it's one equation. So like basically my equation with dollars is here, and then my total children, total adults, total attendance. Then multiply this by 4 because I want to get rid of the A variable because it only asks for how many children, so I don't need to figure out how many adults, I just need to figure out how many children. So multiplied by 4, if it asked how many adults, I would have multiplied by 1.5 to get rid of the C. Subtract and solve, and we can see that we have 1,500 children attending the pool that day. Thanks for going along with a slightly odd video. If you have questions about either of these 2 systems of equation assignments, please don't hesitate to ask for help, and I will be available on Zoom, email, and in Google.